Good morning, students. So today we are going to start with the new topic, that is the gear trends. That is the fourth module which we have not covered in our theories. Okay. So because of some time constraint, I am covering this whatever the topic. Okay. So gear trends. What is gear trends? Before that, we are going to study with the gears. What is gears? Gears are two-third members which are used to transmit the motion power from one shaft to the another shaft. Okay, so preferably whatever the gears which you are using, it is mainly used to transmit the power. Where it is transmitting between the two shafts, means you are using the two shafts. In that shaft, you are going to transmit the power. Okay, means without any slip. So in the belt drives there is some type of slip which is going to be occurs, but in the gears we are not having any type of slips. Okay, the center distance between the two shafts is small, so that is also one of the criteria in the gear trends. So in the gears, that the whatever the distance between the shaft should be small. So if we have the larger distance, then we are not preferring the gear trends. Gear whatever the for the transmission, only two gears which are not going to be used. We are using more than two gears. So trains are nothing but the number of vehicles or gears which are connected with each other. So that type of formation is called as a trains. Okay. So gear trains. What is gear trains? If power is transmitted between by using more than two gears, then the arrangement is called as a gear train. Okay. So if you are using the power and you are transmitting it in between the gears, but you are using more than two gears, not just two gears, you are using more than two gears. So such type of formation is called as a gear train. It is mainly classified into four types. One is simple gear trains, compound gear trains, reverted gear trains, epicyclic gear trains. For your syllabus, you are having only simple gear train and compound gear train. So then we'll move on to the velocity ratio. So velocity ratio is nothing but the ratio between the two gears. Okay, the ratio which is occurs between the two gears, which is considered as a velocity ratio. It is defined as the ratio of angular speed of a driver gear to the angular speed of the driven gear. Yes, you are having the driver gear and driven gear. Means if you are having the two gears, one is the power transmitting gear and one is the power receiving gear. So that's why the one is the driver gear and another one is a driven gears. Okay, so the ratio of that speed between the two gears is called as a velocity ratio. In here, W1 is the angular speed of the driver gear and W2 is the angular speed of the driven gear. Okay, it is taken as the RPM, rotation per minute. We are taking the unit of this angular speed. So you can also take it as a N1 and N2. So N1 is the speed of the driver gear and N2 is the speed of the driven gear. So train value, what is train value? It is nothing but it's a reciprocal of velocity ratio. It is reciprocal of velocity ratio. It is defined as the ratio of speed of driven gear to the angular speed of the driven gear. Okay, so that is W2 by W1. It is W1 by W2 when velocity ratio, but it is W2 by W1, or you can take N2 by N1. Okay. So if you go to the direction of sense of rotation, it is not required for you. Okay, we will move on to this thing. Okay, simple gear trains. Okay, what is simple gear trains, which we have discussed in the classroom? This is the diagram of the simple gear train. If they ask in the exams, you have to write these two diagrams. So in the simple gear trains, we have single gear for each shaft. You can see there is a shafts which are center in here: shaft A, shaft B, and shaft C. Okay, so the shaft is having the gear 1, shaft B is having the gear 2, and shaft C is having the gear 3. So each shaft is having single gear. Okay, each shaft is single gear and it is meshing with each other. So the gear 1 is meshing with the gear 2, gear 2 is meshing with the gear 3. And you can see the gear 1 is having the speed N1 and gear 2 is having the speed N2 and gear 3 is having the speed N3. And the N1 gear is having the teeth numbers, that is Z1, and N2 having the teeth numbers Z2, and N3 is having the teeth number N3. Means the teeth of the gears are represented in the Z term. Okay. So you can see here the simple gear trains, each shaft carries only one gear. All the gears revolve about its fixed axis. Okay, it's only having its own fixed axis and it is revolving around it. The velocity ratio, the N1, there is some simple formula I have to find in here. N1, N2 and N3 are the speed of the gears 1, 2, 3 respectively. Okay, and Z1, Z2, Z3 are the number of teeth on the gears for the respective gears, that is 1, 2, 3 gears. Okay, consider gear 1 to be the driver gear. So what we do, this is the driver gear we will just consider in here. So driver gear is a power transmitting gear. Okay, so the velocity ratio of gear 1 and 2, okay, the gears 1 and 2 velocity ratio, it is nothing but n1 by n2, which is equal to z2 by z1. Okay, that is taken as the equation 1. Similarly, the velocity ratio of gear 2 is and gear 3 is taken as n3 by n2 by n3 and z3 by z2, means the velocity ratio between first two gears and second two gears. Okay, so that is the thing which you are going to take in here. So this are the two equations you are going to get in here. Okay, how this equation came, n1 by n2 is equal to z2 by z1 is nothing but initially there is a equation, that is n1 z1 which is equal to n2 z2. Okay, so n1 z1 is equal to n2 z2. In here we are going to take that ratio as a n1 by n2 is equal to z2 by z1. Okay, so like that we are going to get the two equation. So multiply this two equation, we are going to get n1 by n2 into n2 by n3, which is equal to z2 by z1 is equal to z3 by z2. So in common terms you can cancel out. The n2 n2 is common in here, so you can cancel out. And in here z2 and z2 is common, so you can cancel out. And the final equation you are going to get is n1 by n3 is equal to z3 by z1. So this is the velocity ratio equation for the simple gear train. Therefore, the velocity ratio VR is independent of number of intermediate gears used. Means whatever the gears which you are using, okay, in the simple gear trains, this is the intermediate gears. Okay, the velocity ratio is in the simple gear train is always between one and last gear, driver gear to the driven gear. These intermediate gears are not going to affect on the velocity ratio to this in here. So that they have saying in here. It is mainly the middle gears are called as the idler gears. Okay, so the gear 3 is called as a driven gear. The direction of rotation of the first and last gear is same if the odd number of intermediate gears are going to be used. If the driver and driven gears are opposite direction, if there is a even number of idler gears are going to be used. Okay, means if you are using the gears, you can see in there, this is a driver gear and driven gear. In between these gears, we are using a number of gears. Okay, in here only single gear is present, so it is odd number. In this type of situation, these two gears rotate in a same direction, means it is rotating clockwise, it is also rotating clockwise. So if it is number of gears in between this driver and driven gear is even, for example two numbers of gears present in between this one driver and driven gear, then the opposite, the whatever the gear 1 rotates in opposite direction to the gear last gear. Okay, so this is the thing which we are explaining in here. Okay, and this is the train value, it is opposite of the idler gear. And what are the applications? Gearbox, automobile, lathe machines, heavy duty press machines. There are a lot of applications of the gear trains. Next, move on to the gear, compound gears. In here you can see the shaft A is having one gear, but shaft B having two gears, that is gear 2 and gear 3 is present on the same shaft. Okay, this is the same shaft which is having two gears, 2 and 3. So this is called as a compound gear. Okay, so this is called as a compound gear. The single shaft consisting of more than one gear is called as a compound gear. And the last gear is also having the one gear and one shaft. So always in the compound gears, the first gear and the last gear having same, there is only single gear and single shaft is present. In between gears which is present which are compound gears. Okay, this is represented in here, one gear 1. In here the shaft 2, the shaft B is consisting of gear 2 and gear 3, and shaft C is consisting of 4. So if you see this speed, the gear 1 is presenting N1 speed, gear 2 is having the N2 speed, gear 3 is having N3 speed, and gear 4 is having the N4 speed. And gear 1 having the number of teeth, that is Z1, gear 2 is having the number of teeth, that is Z2, and gear 3 is having the number of teeth, Z3. Similarly, if you go to the gear 4, the number of teeth is Z4. Okay, but you can see in here the middle gear, the shaft is same. So since the speed is also going to be same, the speed of these two gears also going to be same. Why? Because it is having the same center shaft. So how the shaft rotates? The both gears are going to be in the rotates in the same direction with the same speed. So that's why the N2 and N3 speeds are equal in this compound gear. We'll see in next. In the compound gear trains, each shaft carries two or more gears except the first and last gear. Okay, except the first and last gear means this first gear and last gear, except that the middle gears which is having more than one gears. Okay, one of which act as a follower and the other is acting driven. Okay, all the gears revolves about a fixed axis. That is also present in here. So how to find the velocity ratio of this compound gears? Okay, in here the velocity ratio, there is a thing in the figure, the gear 2 3 consisting of compound gear, since both gears are mounted on the same shaft. Gear 1 is a driver and gear 3 odd as a driven. Okay, let n1 n2 and n4 n1 n2 n3 and n4 are the speed of the gears is of 1 2 3 4 respectively. Z1, Z2, Z3 and Z4 are the number of teeth on the gears 1, 2, 3, 4 respectively. Okay, but N2 and N3 is a compound gear. Okay, and so that's why it is N2 is equal to N3. So let's see, gear 1 is meshing with the gear 2. You can see in the diagram, gear 1 is meshing with the gear 2. So we can take the velocity ratio of these both gears. So that is in here. The velocity ratio is equal to N1 by N2 is equal to Z2 by Z1. Next, the gear 3 is meshing with the gear 4. So we can see the gear 3 is meshing with the gear 4. Okay, so we can take the velocity ratio of these two gears, that is N3 by N4 is equal to Z4 by Z3. Okay, so then multiplying these two equations, you are going to get N1 by N2 into N3 by N4, that is Z2 by Z1 into Z4 Z3. So the velocity ratio we are going to get, we can cancel out the common term, that is N2 and N3 are having the same speed. As per the compound gear, N2 and N3 are having the same speed. So that's why you can cancel out. These are the equal speeds. So you can cancel out and you can take N1 by N4, which is equal to Z2 by Z1 into Z4 by Z3. That is the equation given in here. So that is the velocity ratio of the compound gears. This is important equation for the compound gear velocity ratio. If you go to the train value, the similar opposite of this, what of the velocity ratio you are going to get. Okay, so this is the thing. The same thing, direction of rotation will be same as in the simple gear trains. If there is a middle gears even, then you are going to get the rotation in the opposite directions of the both driver and driven. If the gears are odd, then the rotation which you are going to get, it is even. I mean same direction of rotation you are going to get in the both the driver and driven gear. Okay. And what are the advantages of compound gears? It is larger, means in the compound gears we can achieve the larger velocity ratio. So what is the larger velocity ratio? Means we can transmit more power. Okay, and we can increase the shaft difference. So we can transmit the power between the some larger space compared to the earlier thing. Okay, so that is one of the advantages of the compound gear trains. Automobile gearbox, lathe speed gearbox, lathe machines, lot of applications of the compound gear train. Okay, okay students, this is the theory of the gear trains. We will do the problems in the next video. Okay, so just clearly understand this theory and we will move on to the next theory, next problems. So that will give the brief scenario of how to solve the problems. Okay, thank you for listening to this video. Thank you.